Today we're going to talk about how to graph linear equations, and we're going to talk about how to graph in both standard form and slope-intercept. Before we do this though, we need to go over some important vocabulary. You first need to know what a linear equation is. And a linear equation is just an equation whose graph is a line. We also need to know what an x-intercept is. The x-intercept is where the graph crosses the x-axis. To find the x-intercept, we just let y be 0. We also need to know what a y-intercept is. The y-intercept is the opposite of the x-intercept. It's where the graph crosses the y-axis. And here we let x be 0 when we're looking for it. Now let's talk about standard form. Standard form is any linear equation written in the form of ax plus by equals c. A is your coefficient of x, b is your coefficient of y, and c is just a constant. We want to make sure x and y are on one side of the equal sign, and our constant is on the other. We also want to make sure that both a and b are integers, so no fractions, and we want to make sure that a is positive. Anytime we have a linear equation in this form, we say it's standard form. Graphing in standard form is pretty simple. The first thing we want to do is find our y-intercept. Remember, to find the y-intercept, we let x be 0. Once we find the y-intercept, we will plot that on the y-axis. Then we're going to find the x-intercept. To find the x-intercept, we let y be 0, and we plot that point on the x-axis. When graphing a line, we just need 2 points. So once we find the y-intercept and the x-intercept, all that we have to do is draw a line. Be sure to use a straight edge and make sure your line is as straight as it possibly can be. And make sure to use arrows on the ends because we are graphing lines. We're not graphing line segments. Let's go ahead and look at an example. I've got 2x minus 3y equals 12. Here I know it's in standard form because I have x and y on one side of the equal sign and my constant on the other. My a is 2 and my b is negative 3. Both of these are integers, so I can go ahead and start finding my y-intercept. So let's do that. To find the y-intercept, what I want to do is go ahead and let x be 0. So I have 2 times 0 minus 3y equals 12. So 2 times 0 is 0. That leaves a minus 3y equals 12. And if I divide both sides by by negative 3, I get 12 divided by negative 3, which is negative 4. Now my y-intercept is not just negative 4. You want to think about the y-intercept being a point. So what it really is, it's going to be the point 0, negative 4. And this is saying when x is 0, y is negative 4. So once I find the y-intercept, I go and grab my point. I can go over here to the origin. I need to go down to negative 4, and I'm going to plot my y-intercept. Then I want to go and find the x-intercept. And to find the x-intercept, this time I'm going to let y be 0. So I have 2x minus 3 times 0 equals 12. And so here, the minus 3 times 0 will go away. It's going to leave the 2x. So I have 2x equals 12. So x equals 6. Now, my x-intercept is not x equals 6. Okay, remember, it's going to be a point. So my x-intercept will be the point 6, 0. And again, that's saying when x is 6, y is 0. So I go down here, I pick up my point, I go to the origin. I'm going to go over to 6 on the x-axis, and there's my x-intercept. So once I have my 2 points, all that's left to do is connect them with a line. And I want to try to be as straight as I possibly can. I want to use a straight edge. I want to make sure that I have arrows on both ends of my line. And I do. And there you go. There's the line. So that's how you're going to graph something in standard form. Now some of you may have recalled from other courses or other experiences with standard form, you could use something called a cover-up method. So I could take this box, I could cover up the x in order to find the y-intercept, or I could cover up the y to find the x-intercept, and it's going to give me the same results. Let's go ahead and look at one more example. Here I've got 5x plus 2y plus 20 equals 30. It looks like standard form on the surface. I've got x and y on one side. My a is a 5. My b is a 2. However, I've got a constant on the right-hand side and a constant on the left-hand side. So that means I need to do a little manipulation in order to get my equation in standard form. So what I'm going to do is I'm going to have to move this 20. So I need to find the inverse of a plus 20, which would be a minus 20. So I'm going to subtract 20 from both sides. And I'm going to end up with 5x plus 2y. And if I subtract 20 from both sides, 30 minus 20 is going to be 10. So here would be my simplified equation. And this is just an equivalent way of expressing this, but here I've got x and y on one side, and I've got all my constant terms combined on the right-hand side. And then from here, I can go ahead and decide what is my y-intercept, what is my x-intercept. So to find the y-intercept, again, I'm going to let x be 0. So I have 5 times 0 plus 2y equals 10. And the 5 and 0 will go away. And that's going to leave me with 2y equals 10. And then I'm going to divide both sides by 2, so y would be equal to 5. And your y-intercept is not going to be just y equals 5. Your y-intercept will be the point 0, comma, 5. Remember, this is saying when x is 0, y is 5. So I go down here, I graph my point, I go to the origin, I want to go to the point 0, 5, so I'm going to go up 5 units. 3, 4, 5, and there you go. Then I need to figure out what is my x-intercept. And remember, to do that, I'm going to let y be 0. So I've got 5x plus 2 times 0 equals 10. And the 2 times 0 will go away. So that will leave 5x equals 10. Ooh, my pen won't behave. There we go. And so x equals 2. So that means that my x-intercept will be the point 2, comma, 0. And this is saying when x is 2, y is 0. So I'll go, oops, I lost my point. Let me get it back. So be the point 2, comma, 0. So I'm going to graph my point. I go to the origin. I go to the right 2 units, and there's 2, 0. Once I have my 2 points, I'm ready to connect my dots. And there we go. There's my line, and I'm done. So graphing in standard form is pretty simple. You just want to make sure x and y are on one side, your constants on the other, and then you're going to find your x and your y-intercept. And of course, you can use the cover-up method where you could cover up the term with the x in it to find the y-intercept, or you could cover up the y to find the x-intercept. Just remember that the x and y-intercept, they are points. They are not just x equal or y equal. Now let's talk about slope-intercept. Slope-intercept is the one that you're most familiar with. Slope-intercept would be y equals mx plus b. Here you're looking for equations that have been solved for y. If they've been solved for y, then finding your slope and y-intercept is quite easy, and graphing is much faster than in standard form. Here, your slope is going to be the coefficient of x. That's what the slope is. And remember, slope is rise over run. It's the change in your y's over the change in the x's. The constant toward the end is your y-intercept. And this is going to be the point that we graph on the y-axis. It's where the graph crosses the y-axis. So let's go ahead and look at the steps. The first thing you're going to do is find your y-intercept. We're going to begin with b. Your first point will always be on the y-axis. After I graph my y-intercept, I'm going to find a new point using the slope. So from the y-intercept, I will move with the slope. We begin with b and move with m. Finally, we're going to connect our dots and draw our line. So let's look at an example. Here I've got y equals 2/3 x minus 4. Let's look at the general form for slope-intercept. I've got y equals mx plus b. Remember, if it's solved for y, all you have to do is find the coefficient of x for your slope, and the y-intercept will be the constant term. So if I look over here, my coefficient for x is 2/3. So that means my slope will be 2/3, 2 over 3. My y-intercept is going to be this minus 4. You want to make sure you pick up the sign right here. So the y-intercept is going to be -4. So we begin with B. That means our first point will be at the point 0, -4. That's your y-intercept. So I'll go down here, I grab my point, and I go to 0, -4, which would be right there. Once I have my y-intercept, I'm going to move from this point in the direction of the slope. Now my slope is 2/3. The numerator is your y direction, your denominator is your x direction. So I'm going to move up 2 units, 1, 2, in the y direction, and then to the right 3 units. That would give me the +2 and +3. I could keep going up and over to find additional points. So I'd have a point here and a point here. Now if I wanted to, instead of going up 2, I could go down 2. Now if I go down 2, that's negative. So that means that would be like a -2 on my numerator. Well, if I have -2 on my numerator, what would I need to do to that denominator so that it would be equal to 2/3? It has to be negative, right? So that means if I go down 2, I have to go to the left 3. So I'm going to go 1, 2, 3. And that would be another way I could get a point on my graph. So that's more than enough that we need to graph the line. So I'm going to go ahead and connect my dots. And I'm done. That's it. The graph is complete. So we begin with B and move with M, and pay attention to your slope. Remember, there are different ways that you can move. This was a +2/3, so first I went up 2 and to the right 3, and then when I went down 2, that was a negative direction. To keep this positive, I have to go in another negative direction, so that's why I went -3. Now let's look at another example. I've got y equals -3/4 x plus 2. So it's solved for y. The coefficient of x is -3/4. So that means my slope is going to be a -3/4. Now when you have a negative sign, attach it either to the numerator or the denominator. So the slope could be -3/4, or you could say that it's 3/-4. Either one is correct. Just remember, only either the numerator or denominator will have the negative sign, not both. Okay, that's the big thing. Now the y-intercept, remember, is the constant at the end. Usually it's at the end. So the y-intercept is going to be at 2, which means it's going to be the point 0, 2. So I'm going to begin with plotting B. I go to the origin, I go up to 2 and put a dot. From this dot, I move in the direction of the slope. So let's say I do -3/4. So that means if it's -3, I go down 3 units, 1, 2, 3, and then the 4 is positive, so I go to the right 4, 1, 2, 3, 4. And that's where I would put my point. Now if I wanted to, I could look at the other one, and I could go up 3, which is the +3, 1, 2, 3, and then the -4 would be this way to the left, 1, 2, 3, 4. So that would get me another point. Remember, to graph a line, you only need 2 points. So I could have either just gone up or just gone down. It doesn't really matter. You just need 2 points. Now, let me connect my dots. And I have my line. And I'm done. So graphing a slope-intercept is so much faster than graphing in standard form. If you have your equation solved for y, you just find your slope, and you find your y-intercept, and you plot your y-intercept and move in the direction of the slope. Now I do want to look at 2 special cases. Let's look at this one, y equals 4x. Now remember, slope-intercept form is y equals mx plus b. And I look at y equals 4, and I don't see an x anywhere. So if I want to make this fit the form y equals mx plus b, I could think about it being y equals 0 times x plus 4. And if I do that, I can see that my y-intercept is at 4, because that's this right here. So that means my y-intercept would be the point 0, 4. Okay, so let's go ahead and plot that point. So I go to 0 and go up to 4. There's my point. Now, my slope. My slope is 0. The coefficient of x is 0. So from this point, I can't go up, down, left, or right. It's just sitting there. So what does that mean? How do I figure out the rest of my points? Well, let's think about this. Let's say I let x be 2. So I'd have y equals 0, which is the slope, times 2 plus 4. Well, what happens is the 0 times 2 goes away, and I still get y equals 4, which would be the point when x is 2, y is 4. It turns out no matter what I pick for x, it's going to get multiplied by 0, it's going to go away, and the y value is always going to be 4. So what happens is, let's say if x is 2, y is 4. If x is 5, y is going to be 4. So here, no matter what I pick for x, my y value is always 4. So what happens is, when I draw my line, I'm going to end up with a horizontal line, just like that. So anytime you have a y only in an equation, that means your line is going to cross the y-axis and you're going to have a horizontal line. So remember, y only means a horizontal line. Now let's look at an x only equation. Now if y only is horizontal, it's going to make sense that x only is not going to be horizontal. And this one takes a little bit to understand. Here, there's an x, but there is no y. So I can't really relate it back to slope-intercept because there's no y here. What I do know is that x is 6. So if x is 6, then it doesn't matter what y is. The x value is always 6. So what happens is, let's say if y is 0, then that means x is 6. If y were, say, 4, then it would be 6. So here, I'd have something like this. So it wouldn't matter what value I picked for y, the x value would always be a 6. So what happens is, instead of having a horizontal line, I'm going to have a vertical line, just like that. So if you have an x only, you're going to have a vertical line. That means no matter where I am on that line, the x value is a 6. A y only is going to be a horizontal line. So no matter here, no matter what my x was, my y was 4. So y only is horizontal and x only is vertical. So it just takes a little practice and a little bit of studying. So today we talked about how to graph in standard form, how to graph with slope-intercept, and we also looked at horizontal and vertical lines. So go back over this, study it, come to class, and be ready. See you later.